Hello, welcome to next session. In this session, we will solve production paper of year 2020, okay, of GATE exam. We have already solved one mark question, okay. Now, in this session, we will solve only two marks question, that is 26 to 55, question number 26 to question number 55, okay. So, question number 6, the general solution of x square d square y by dx square plus x dy by dx minus y is equal to 0 is option A. Y is equal to c1 by x plus c2 by x cube. B. Y is equal to c1 x square plus c2 by x square. Option C. Y is equal to c1 x plus c2 by x. Option D. c1 x plus c2 x cube. Okay. So here the differential equation given is that x square d square y dx plus dy by dx minus y is equal to 0. So now we can put x is equal to et, then the x dy by dx will become dy and x square d square by dx square will become d minus d bracket d minus 1 y. Okay, where d is the d by dt. Okay, so this is the Churchy demand for okay. So putting these values, we can have this um, this quantity as d minus 1, and this quantity as d, and this quantity as minus 1. Okay. So here from this we can get d is equal to plus 1 and d is equal to minus 1. Okay. And the general solution is your C1 ET plus C2 E minus T. Okay. So ET is your X. Okay. E recorded is your X. So because here it should be D1 T and it should be D2 T. Okay, D1 is your plus 1 T and D1 is your D2 is D1 is your plus 1 T and D2 is your minus 1 T. Okay. So it is ET minus ET. If putting ET is equal to X, so the answer will be your C answer. Okay. So question number 26, C answer. Next question is also mathematics. For the matrix 1, 5, 3, 3, the eigenvectors are option A 1 minus 1 B 3 and sorry 3, 3 minus 3. The options are given. Okay, these are the options. So let us find out the eigenvector. Okay, so this is the matrix given. Okay, to find out the eigenvalues, we will subtract lambda here on the diagonal matrix. Okay. So now solving this matrix, we can get lambda is equal to 6 and lambda is equal to minus 2. These are the eigenvalues. Okay. So now corresponding to eigenvalue minus lambda minus 2, the general form of the eigenvector is this a minus lambda I x 0. Okay. So here lambda is minus 2. So and matrix is A matrix is 1, 3, 5, 3. So it will be 1 plus 2 here and 3 plus 2 here. And this matrix X is XY. So we have this 3, 5, 3, 5. Okay. So the general so solution is 3x 5 y. So the eigenvector is your minus 5, 3, 1. Okay. From this and corresponding to 6 in a similar manner, we can have this. Okay, x is equal to y or we equal to 1. So correct option is minus 5 by 3 and the option is B. Okay. Next. Next is question number 28. It truss with two bars PR and QR making angles alpha and beta respectively with the vertical in the is shown in the figure below. The connections at P, Q and R are hinged connections. The truss supports a body of weight W in Newton at R as shown. The tension in the bar QR, the tension in the bar QR in Newton is, these are the options. Okay. So just use Levi's theorem. Okay. W by sine of this angle. Okay. You have to find out the number, the floating number Q. W by this sine of this angle and Q by sine of this angle. Okay. W by your sine alpha plus beta. Okay. W by sine alpha plus beta into sine this angle, that is 180 minus alpha of sine alpha. So answer should be B. So answer is W by, answer should be D. So W by this angle, okay, and R by this angle, 180 minus alpha. Okay. So sine 180 minus alpha is sine alpha. So answer is here B. Okay. W by this angle, R by this angle, and sine 180 minus alpha is your alpha. So answer is question number 28 is your B. Okay. Next, figure shows a beam of length L in meter with a uniformly distributed transfer load of W in Newton per meter acting over it. The width and depth of the beam cross section are B in meter and T in meter, respectively. The magnitude of maximum bending stress in the beam in Newton per meter square is, so this is the beam and with UDL, okay. So as UDL is given as W in Newton per meter, okay. So we have to calculate the bending stress. The bending stress will be maximum because it is a UDL and the shear force is changing at this point. So the bending moment at the midpoint is, bending moment at the midpoint is your WL square by 8. Okay, maximum will be at midpoint. Okay, WL square by 8 in UDL. You can remember the formula or you can calculate W by 2 into L by 2 minus W by 2. Okay, into L by 4. Okay. Taking movement from one of the sides. Okay, M max is W square by 8. Okay, then using bending equation, we have M by I, sigma by. So M is your W square by 8, I is your BT, 2 by 12. So sigma is, you can find out sigma by putting 1 into 3 by 2. So that is 3 by 4 WL square BT square. Okay, so question number 29, answer A. Next, the vertices of rectangle PQRS are as follows in a 2D CAD system. P is equal to minus 4, P bracket minus 4 minus 2, Q minus 4 minus 3, R minus 3 minus 5, S minus 5 minus 4. Okay, the coordinates of the corresponding new vertices P dash, Q dash, R dash, S dash after translation of rectangle along the along x-axis in positive direction by 6 units and along y-axis in positive direction by 3 units are. So these are the options. Okay. Now P dash. Now we are adding x is equal to 6 in x direction and y is equal to 3 in y direction. So just add in x coordinate by 6 and y coordinate 3. So minus 4 plus 6 is your 2. Okay. So answer will be according to P or B or C. So there are 2 and here it should be minus 2 plus 3 plus 1. So answer is P. Sorry, B. Let us see. So adding by increasing the x by 6 units and y by 3 units. Okay. So minus 4 plus x minus 3 plus 2 plus 3. Okay. Minus 2 plus 6 minus 3 plus 3. Okay. We get the option B as right answer. Okay. So question number 30. Next question. The statement that best describes the function of a go gauge in the context of Taylor's principle of gauging. Option A, go gauge checks maximum material condition and is designed to check as many dimensions as possible. Okay, that is the right answer because go gauge means the metal has to pass through. Okay, so if the metal doesn't pass through the go gauge, then it has the excessive material on it. Okay, so this is the maximum material condition, and we have to check as many as we can. Like in cricket, the ball passes through go gauge and doesn't pass it through not go gauge. Okay, so it is the maximum material that the ball can have. Okay, so this the answer is A. So these are other options. Go gauge check the least material no. Go gauge check the maximum material condition and is to check only one dimension. All the dimensions are checked. Okay, the go gauge checks least material condition no. Okay, so answer is A. 31. Next, in figure, the revenue generated over a product life cycle is marked as P, Q, R, and S. Group 1 lists these product life cycle stages. Group 2 lists typical effort leading to revenue maximization during the stage. Okay. Group 1 P is introduction, Q is growth, R is maturity, S is decline, and in group 2 1 effort to enhance production capacity, B 2 effort to regenerate the product, 3 effort to maximize the product performance, 4 effort to explore other markets. Okay, you can see the P is your introduction. Okay, so it is the effort to maximize the product performance. So answer is so this is also the theory based question. Okay, so answer is your B. So P introduction P is effort to maximize the product performance. Second phase is growth. The Q phase is growth. Okay, so this Q is your one effort to enhance the production capacity. Okay, in this we will see at product performance and then we do the product performance has been selected. Okay, it is found good, then we will increase the production capacity. Okay, then maturity and after some time the maximum demand of the product reaches. Okay, and and after that there is decline in the demand also. Okay, so answer is your D. Okay, answer is D. Next. The company manufactures products P and Q in quantities X1 and X2 respectively, using two resources. The following linear programming problem LPP is formulated to maximize the profit Z. Maximize Z 3x1 is equal to 3x1 plus 2x2 uh, subject to x1 plus 2x2 constraint less than equal to 2 2x1 plus x2 less than equal to 2 for resource 1 and for resource 2 and x1 and x2 are greater than equal to 0. Okay. The shadow price for resource 2 is option A 0, option B 2 by 3, option C 1 and option D 4 by 3. Okay. First of all, we have to understand what is shadow price. Okay. So first of all, we take the given condition. These are the given constants and we have to maximize this and we find the maximum value of that. Okay. Now drawing 2x1, x2 as like this by putting x2 is equal to 0. We have x1 as 1, so say 1 and x2 as by putting x1 is equal to 0. Then we have x2 as 2. This is the line. Similarly, by putting x1 is equal to 0, we have x2 as 1. Okay, and x2 is 0, we have x1 and 2. So this is the intersecting point, and this is the required visible region. Okay, and at B will have at we can have maximum profit at C, B, or A. Okay, so finding a maximum profit. So it is at B. So this is 2 plus 4 by 3. Okay, so maximum profit is at B. Okay, now according to the given condition, we have found the maximum condition. So these are the lines. Well, let us derive. Okay, these are the lines. The result. These are equal solutions. These are so at point C, Z is 2, at point A, Z is 3, and at point B, Z is the first of all find out the point B by solving these two equations. Okay, so the point B is x2 is 2 by 3 and x1 is 2 by 3. So at point Z, sorry, at point B, the Z is Z 2 plus 4 by 3, that is maximum value. Okay, so Z is maximum at B. Okay, now the shadow price. What is shadow price? It has been asked that shadow price for resource 2. Okay, the resource 2 is this. Okay, the shadow price is defined as the price if we increase the constraint by of resource 2 of that resource for which the shadow price has now. If we increase the constraint by 1 unit, what is the effect on what is the effect on the maximum profit? Okay, that is the shadow price. Okay, so when we so second constraint is your 2x1 plus x2 less than equal to 2. Now when it is uh, increased by 1 unit, it will become 2x1 plus x2 less than equal to 3. Okay. Now solving these two conditions for point B, we will have x is equal to 4 by 3, x1 is equal to 4 by 3, and x2 is equal to 1 by 3. So z is equal to 4 plus 2 by 3. Okay. So the difference in z, okay, is the shadow price. So increase in the shadow price of, sorry, the difference in z due to increase in the constraint by 1 is the shadow price. So now the initial profit was 2 plus 4 by 3. Okay, now when the constraint is decreased by 1 unit, so the profit is here 4 plus 2 by 3. Okay, so the difference of these two is shadow price to resource 3, that is 4 by 3. So answer is your D. Okay, answer is D. Next, a rectifying inspection is performed on a lot of size n is equal to 1000 using single sampling plan with a sample size n is equal to 60. Okay, and the acceptance number C is equal to 1. If the acceptance quality level is 1%, the producer's risk associated with the sampling plan rounded off to nearest integer in percentage is option A 12, option B 33, option C 67, option D 88. Okay, so we know that this is the quality curve or quality characteristics curve. Okay, this is the manufacturing mix, and this is the consumer mix, and this is the quality level. Okay, so at uh, quality level acceptance as quality level acceptance at 1%, it is nearer to the y-axis, and the manufacturer risk is 12%. No other option is very close to that curve, to that region. Okay, it may be 10%, maybe it may be up to 20%, but so the lowest option will be your 12. So answer is 12. Okay, so this is your quality curve. This is acceptance quality level. This is your probability of acceptance. Okay, this is your manufacturer risk. This is your consumer risk. Okay, when the quality is 99% accurate, okay, okay, then sorry, when the quality is 99% accurate, then the probability of acceptance is according to this, and still there is a manufacturer risk of 12% acceptance. Probability of acceptance is your 98%. Okay, so when AQL is 1% or less, it is the probability of acceptance is more, or the producer's risk or manufacturer risk is less. So answer is A. Okay, next. For y is equal to minus x square plus 9x minus 2. The value of integration phi 1 y dx using Simpson's 1 by third rule with two intervals rounded off to two decimal places is. So this is the integration we have to perform by using Simpson's method under rule. Okay. Now the integration limits are 1 to 6. Okay. So at so we are taking the interval as oh, sorry 1 to 5. So there are we have to take the 6 interval. With two intervals. Okay, rounded up to with two intervals. Okay. Now we have to take only two intervals. So here we have to take only two there, but we have taken here five intervals. Okay, six intervals. So answer will be approximately the same. So answer is 35%. So answer is same. Okay. So this is the basic concept is that you have to take only two interval, but here I have taken six interval to be more accurate. Okay, you can take two interval also. Okay, so when we take six interval, then it is the interval width is 5 minus 1 by 6. Okay, that is 0.667. So at x is equal to 1. Okay, at x is equal to 1, y is equal to 6, and at uh, x is equal to 1.667, and y is equal to this, and add add 0.667 in each of these values x and find out value of y according to this. Okay. Then according to Simpson's rule, we can use this also. H by 3, the formula is h by 3 y naught plus last of this y6 plus 4 y1 plus y3 plus y5. Okay. Plus 2y1 plus y4. Okay. So this is the formula for this, and that is the interval here. Okay, so by putting this value, we can find out 58.68. So answer is here 58.68 between 58 and 59. So you can use the two intervals also. So two intervals, then the two intervals will be 5 minus 1, 4, or divided by 2. So it will be of 2 and 2. Okay, so you will put here 1 and 3. You can take these 2. 1 3 these two values 1 by 6 and 5 by 8 and 3 by 8. Okay. Then you can use y naught plus this y3 plus 4 this. Okay. Answer you can get the answer. This is also accurate. Okay, because we are getting the right answer. Next, a solid sorry the if the probability density function of a random variable x is given by fx is equal to kx square by 2, 0, minus 1, x is varying from, sorry, x is varying from minus 1 to plus 1. Okay. Now we integrate it. Okay. Then the total, this is a probability density function. Okay. If we integrate it, then we get the total probability, and the total probability cannot be more than 1. Okay. And by using the concept, we can find out k. Okay. So this is the total probability will be integration of this, that is x is equal to minus 1 to 1. So that total probability of any system cannot be more than 1. So putting this value, okay, we get k is equal to 3. So answer is 3. Number 36, answer is 3. Okay, next, question number 37. A solid shaft has to transmit 50 kilowatt of power at a speed of 1910 rpm. Ignore any possible bending of the shaft. Maximum allowable shear stress for the material of the shaft is 80 MPa. Minimum diameter of the shaft required to uh, prevent failure due to shear, rounded off to 1 decimal place in centimeters. So here the power is given as 50 kilowatt. RPM is as 1910. Okay. So and maximum allowable shear stress is 80 MPa. So using torsion equation, sorry, using power and RPM, we can find out torque, and then using torsion equation, we can find out diameter. Okay, so this is the concept. So using power and RPM, we can find out torque. Okay, that is 249 9.81 newton meters. Okay, and then using torsion equation, P का J था आया J is your polynomial J for 32 before, and R is your divided 2. Okay, you can find out strength. Sorry, stress is given. So we can find out diameter, that is 2.25.15. Then orange centimeter is 2.515 centimeters. Okay. Next, a flywheel is to be used in an IC engine to limit fluctuation of angular speed. The average of maximum and minimum angular speed is 500 rpm, and the maximum fluctuation of energy is 10,000 newton meter. Neglecting the rotary inertia of any other component, the moment of inertia of the flywheel about its own axis of rotation required to limit the fluctuation of speed to 30 rpm, rounded up to 1 decimal place in kilogram meter. Here is, so the flywheel is the mean speed of the flywheel is 500 rpm. Okay, and maximum speed is, as fluctuation of speed is given as we have to limit the fluctuation by the speed 30 rpm. So maximum speed is your 500 plus 30 by 2. Okay, because fluctuation is maximum minus minimum. Okay, so the maximum speed will be 515 and minimum speed will be 485. Okay, now the fluctuation of energy is given by uh, maximum energy minus minimum energy. The maximum energy I omega square by 2, I max omega square by 2, and minimum energy I mean omega square by 2. Now that fluctuation is given as 10,000. So we'll put e equal to 10,000. Moment of inertia is also given. Okay, moment of inertia is moment of inertia. You have to calculate the moment of inertia. Okay, so all other are given, n max is given. Okay, so we can find out omega max, and n mean is given, so we can find out omega mean. Putting the values, we can find out I. So I is your 60.79 kilogram because the answer for the question is 59 to 62. Okay, so answer is your 60.79. Next, a tank of large cross-section area contains water up to a height of 5 meters as shown in the figure. The The top water surface is under the pressure of P1 is equal to zero point 0.2 MPa and a small smooth and round track at the bottom of the tank is open to atmosphere. P2 is equal to zero point 0.1 MPa. Okay, so this is P2 and this is P1. Okay. Use acceleration due to gravity. G is equal to 9.81 meter per second square. Add density of water rho is equal to 1000 kilogram per meter cube. The velocity with which the water will exist from the tap under conditions shown in the figure rounded off to one decimal place in meter per second. So here the pressure is 0.2 MPa, okay, and here the pressure is 1.1 MPa, and difference of level is 5. We can apply the Bernoulli. Here the velocity can be taken as 0, and here the velocity we have to find out. So we can apply the energy equation, okay, at this point and at this point, okay. So applying Bernoulli's equation add 1 1 and add 2 2. So it will be P1 by rho g plus V1 square by 2g plus Z1. Okay, and here it will be P2 by rho g and V2 square by 2g plus Z2. Here V1 is 0, P1 is 0, that is zero point 0.2, and rho is 1000. Okay, and Z is 5 meter. Okay, and V2 is here, we have to find out. Okay, so in Z2 is 0, so answer is here 17.27 meter per second. Okay. So answer to question number 59 is 17.2. 17.2. Next, question number 40. A steel ball of 12 mm diameter is heated to 1225 Kelvin. It is then slowly cooled in air to a temperature of 475 Kelvin. During the cooling process, the ambient temperature is 325 Kelvin and the heat transfer coefficient is 30 watt per meter square Kelvin. Assume density of steel is 7800 kilogram meter per meter cube and specific heat is 600 joule per kilogram per Kelvin. Using the lumped capacitance method of analysis, calculated time for the required cooling rounded up to one decimal place in seconds is. So the diameter of the ball is d is equal to 12 mm. Okay. Now for the as ball is sphere, so for the ball for a sphere the characteristic length is d by 6. Okay. So this is the d by 6. Okay. Basic characteristic length. Okay, and heat transfer coefficient of the liquid in which the ball is submerged is 30 watts per meter square. And the specific heat of the liquid is Cp is 600. Density is your 7800. Okay. Now to apply a lump parameter, we have to check the Boyd number. So if the Boyd number is less than zero point 0.1, then we can apply the lump number parameter. Okay. So here the Boyd number is H by L by K. So H is your 30 and L is your 12 into 12 by 1000 by 6. Okay, and K is your and K is given. K is not given. Okay, K is not given. Okay, thermal conductivity of the ball is not given. Okay, so we cannot check the Boyd number. Okay, so but the Boyd number should be less than zero point 0.1. Okay, because he has given that you have to use lump parameter, it will be less than 1. Okay, and now calculating the another number that is used in RCD transfer, that is 14 number, that is alpha tau by L square, where alpha is thermal diffusivity and tau is your time, L is characteristic length. Okay. Now thermal diffusivity is K by rho Cp, and K is also K is again the conductivity and rho is density in Cp is specific. Now in a lumped parameter we use this P minus Ta divided by Pi minus Ta is equal to T minus Biot number into effort into porous number, where T is the temperature of the ball after time T. Okay, and Pi is the initial temperature and Ta is the atmospheric temperature or the temperature of surrounding. Okay, so by putting this Biot number into porous number, it will cancel out. Okay, and this product will be equal to your 0.003205 tau in terms of tau. Okay, so and t and you have to calculate the time when the ball reaches at 450 475. Okay, you have to calculate the time when the ball reaches at 455. So 475 minus 325 is atmospheric pressure temperature, and your 1125 is initial temperature, and 325 is temperature of the coolant or you can put this. Okay, you can put this, and we can find out uh, tau as 559.05 seconds. Okay. So answer is your 559.0. Question number 40. Question number 40. 557. Okay. Next, next, a mass of 3 kg of argon gas at 3 bar 27 degrees Celsius is contained in a rigid insulated vessel. Pedal bead work is done on the gas for 30 minutes at the rate of 0.015 kilowatt. The specific heat at constant volume Cv for argon is 0.3122 kilojoule per kilogram per degree Celsius. The final temperature of the gas rounded off to one decimal place in Kelvin. So now the mass of the argon gas is 3 kg and pressure and temperature are given. It is in rigid vessel that is influenced and pedal work for 30 minutes of intensity. This is given. Okay, so we calculate the total amount of pedal work. Okay, so this pedal work will be converted into heat. Okay, because that is insulated. The specific heat at constant rate is control CV is your this. So the final we can calculate the final temperature because this is the amount of heat entering in the or amount of work entering in the vessel, and its initial temperature is 27 and volume is constant. Mass is 3 kg and CV is given. So using MCV, temperature change is equal to this amount of work. We can find out temperature. Okay, so question number 41. Okay. So M is 3 kg. Work done is your uh, work done is 0.015 kilowatt, or in for 30 minutes it is this multiplied by 30 into 60 or into 1000. That is into this. So for 30 minutes it is this. So this amount of heat, sorry, this amount of work will be converted into heat. So that will be Q. So this will be MCV. Temperature change. From this we can calculate. Here, that is 55.827 degrees Celsius or 328.82 degrees Celsius. Question number 41. Next question. Question number 42. The figure shows drawing of a part with dimensions and tolerance both in mm. The permissible tolerance for the slot A rounded off to one decimal place in mm is plus minus. So we have to calculate the dimension of the slot. Okay. So this we have to calculate the dimension of this slot. Okay. We have to calculate the tolerance of this slot. Okay. In plus minus. Okay. So this is the slot. Here it is given that this dimension is this maximum dimension can be 100 plus 0.5. Okay, and minimum dimension can be 100 minus 0.5. Okay, because the limits are given. Okay, so the dimension is 100 plus 0.5 and minimum will be 199.5. And for this, the maximum dimension will be 40.1 and minimum will be 39.9. So difference of the maximum and minimum will be the maximum length of 2 and minimum and maximum will be minimum length of 2. Okay, so difference of these and this will be told as 66.6 minus 59.4 will be the total. So, so answer will be sorry. So it will be 1.2. So it will be plus minus 0.6, 0.7 plus minus 0.6. Next, to manufacture a To manufacture a product by casting, molten metal is poured in a cavity of rectangular cross-section in a stand mold with side bilined riser as shown in the figure. The dimension of the mold cavity are 60 centimeter into 40 centimeter into 20 centimeter. Okay. So this is the dimension of this mold cavity 60, 40 and 20. Okay. The riser is cylindrical in shape with diameter equal to height. It is required that the solidification time of the riser should be 25% greater than that of the mold. Using the Krovinov rules, the diameter of the riser in centimeters should be. So the diameter, sorry, the volume of the casting is here this volume. The volume of the mold is this 60 into 40 into 20. Surface area will be uh, 60 into 20 plus 40 into 20 plus 20 into 60 into 2. Okay. And according to Province rule, we have P is equal to B by A square. Okay. So add for this is for casting and uh, for riser from cylindrical shape when D is equal to L. Uh, the- when D is equal to L, D is equal to L. Okay. When D is equal to L, diameter and length are equal. The volume by area ratio is D by 6. Okay. So then it will be T time for riser will be proportional to D by 6 K. Now it is given that the the temperature of the time for riser should be 1.25 of that or 25% more than that of casting. So T by PC by TR is 1 by 1.25. So from this we can calculate diameter that is 36.59 centimeter. So answer is your answer to question number 43 is 36 centimeter. Okay. Next, a cylindrical billet of 90 diameter is extruded to produce an I section as shown in figure. All dimensions are given. So this is the I section. The total extrusion pressure PE in MPa required for above process is given by PE is equal to sigma m zero point 0.8 plus 1 by 2 in ln A naught by A. A naught is initially A is final area. Okay. Where sigma m is the mean flow stress of the material and A naught and A are initial and final cross section area respectively. If the mean flow stress of the extruded material is 80 MPa, the force required for the above extrusion. Okay. So this is also the straightforward question with the formula given. Okay. So here A naught is your billet of diameter. A naught is billet is cylindrical, so A naught is your 90 pi by 490 square. Okay, and AF is your the area of this I. That is 50 to 5, 2 plus 60 to 5. Okay, so this is 800. Okay, now putting this value A naught by AF, okay, and the formula given is A naught by AF 1.2.8 sigma m in your mean flow stress. Sigma mean your mean flow stress is 80 MPa. We can find out P force required. Okay, so this is the, sorry, we can calculate the pressure required. Okay, now the multiplying with the addition area, that is power body square, we can get force required. That is 167.452 kilometers. Okay. Next, the heat generated in resistance sport welding operation for joining two metal sheets with a certain set of process parameter is 2000 joule. For a second sport welding operation on the same sheet without any change in the overall resistance of the system, the current is increased by 25%, and the time for which the current is applied is reduced to half. The heat generated in the second operation rounded off to one decimal place in joules. So this is the heat required, heat generated, okay, 2000. And for the second sport welding operation, uh, when the current is increased by 25%, for which the applied current is reduced to half. Okay. Wait. You have to calculate the heat generated in second case. Okay. So in the first case, the heat generated in 2000, that is I scale RT. Okay. Now I is changed to 1.25 and time is changed to T by 2 in the second case. Okay. Then we will have this I 1 by 1.25 square by 2 I square RT. Okay. Now I square RT is 2000, that is 1562.5 joule. Okay. So answer is here. So two conditions are given. According to first condition, the total heat generated is 2000. Now the in the second condition, the current is changed to 1.25 and time is changed to T by 2. Okay. So you have to calculate the heat required. Okay. Now the IR square T is known or given. Okay. So we can calculate this second heat. Okay. Next, in a vertical boring operation, a vertical boring operation is performed in a cast iron plate to enlarge blind hole to a diameter of 25 mm up to a depth of 100 mm in a single pass. The cutting speed and speed used in the process are 100 meter per second per minute and zero point 0.1 mm per revolution, respectively. Considering the allowances for tool approach as 2 mm and actual machining time, the actual machining time in minutes is. So boring operation has been performed with the velocity of 100 meter per minute. Okay, so we can calculate the RPM. Okay, because cutting velocity of the bore will be 5 Okay, so we can calculate n is your this. Okay, now the length of the or depth of the bore is 100 mm. Okay, so total travel will be and approach is so the total travel is your 1202 mm. Okay, so n is your 21.23 revolution per second and sorry revolution per second and uh, total travel is 1.02 mm. Okay, 102 mm. Okay, and speed is 0.1 mm per revolution. Okay, so this is in revolution per second. Okay, and speed is in zero point 0.1 mm per revolution. Okay, now if we want to calculate the feed in feet per meter second, we have to multiply this and with this f. Okay, then we can calculate the feed in mm per second. Okay, now this bore has to travel 102 mm length with the speed 2.12 3 per second. Now the distance traveled, sorry, then now the time taken uh, by this ball is distance, okay, distance by velocity, okay, 102 by 2.123, okay, that is 48 seconds or 0.8007 minutes, okay. Next, for a particular tool workpiece combination, the value of exponent and in Taylor's tool-life equation is 0.5. If the cutting speed is reduced to 50%, keeping all the other machining conditions same, the increase in tool life in percentage is, so this is now in according to Taylor's equation, we have Vt n by equal to constant. Okay. Now in the first condition, n is given as 0.5. Okay. Okay. Now the V is increased by 50%, so it means V is increased by 50%. So V1 is equal to 1.5. V is because the cutting speed is reduced by 50%. Okay. So V1 will become 0.5 V. Okay. And keeping all the now 0.5 V. Now the as speed has been reduced, so there will be new tool life. Okay. So that new tool life is T1. Okay. So but N and C will be constant. Okay. Now dividing these two, we can get T1 by T2. So T by T1 is equal to N, or 1 by zero point 0.5 is equal to 1. So T by T1 is equal to it was zero point 0.5 and is 0.5 is equal to zero point 0.5. So T by T1 is equal to 0.25 or T1 is equal to 4T. Okay. So the increase in percentage increase in tool life is now new tool life is 40. Total tool life is T. So percentage increase is 40 minus T by T. That is 100. Okay. So next question is, in a water jet machining process, the water pressure is 500 MPa. The diameter of orifice of nozzle through which the water jet comes out is 0.25 mm. Neglecting frictional and other losses and using density of water as 1000 kilograms per meter cube, the mass flow rate of water jet in kilograms per minute is uh, 1. So this is a water jet machine. The pressure is 500 kPa. Okay. So this is the empty point, this is the exit point. Okay. So pressure is 500 kPa. The velocity at 1 is 0. Okay, this is because in water there machining a nozzle is used, which is increasing the velocity at the cost of pressure. Okay, so Z1 and Z2 are same. Okay, so V1 is equal to 0 and V exit we have to find out. So P exit is 0. Okay, because it is atmosphere. Okay, P1 is your 500, V1 is your 0. Okay, so putting this value V exit, you can calculate V exit. V exit is your 1000 meter per second. Okay, so discharge is rho A V exit. Okay, so discharge is your rho A V exit. Okay, so now we have V exit. A as diameter. Diameter is 0.25 mm. Okay, and rho is 1000. So by using this, we calculate 2.94, sorry, 0.049 kilogram per second as discharge. Okay, now we can convert it into kilogram per minute also. That by multiplying by 60. Next, question number 49. The movement along the z-axis of a CNC drilling machine is controlled by using a servo motor. A lead screw and an incremental encoder. The lead screw has two threads per centimeter. It is directly coupled to a servo motor. The incremental encoder attached to the lead screw emits 100 pulses per revolution. The control resolution in micron is okay. Uh, as the lead screw will move in a simple resolution by an amount equal to pitch. Okay, okay. Or as it has two threads per centimeter, so the movement of the lead screw will be 0.5 centimeter. Okay. Now the control resolution is the we have to calculate the control resolution. Okay, what is control resolution? The control resolution is the minimum dimension that can be controlled by the single controlled by single pulse. Okay, by 100 pulses, the minimum dimension which can be controlled by 0.5 into 10, that is 5 mm. Okay, so given that the uh, the incremental was tied to the lead screw of the time is 100 pulses per revolution. Okay, so by 100 pulses, we can calculate this is zero point 0.5. Okay, zero point 0.5 centimeter of 5 mm. Okay, now by one pulse we can have 5 by 100. Okay, so this is the control regulation that is controlled by a single pulse. Okay, that is 50 micron. Okay, next, the project consists of 7 activities as listed in table. The time required for each activity and its immediate processor are also given. So activities are P, Q, R, S, T, U, V, and time required is 74211 994. Immediate processor dash dash Q, P, P, R, Q, P, U. Okay. The project completion time using critical path method is immediate is. So the table is given. So we have to draw the critical path. So we have to draw the project diagram. Okay, then we have to find out the critical path. So first activity is P. So there is seven activity seven. The next activity is Q. So it is, doesn't have immediate figures. Okay, so it will be also taken as starting activity four. Then R after Q. Okay. Then S after P. Okay. Then T after P and R. Okay, so we have to join this. Okay. Next U after Q. So U. Okay. Then V after T and U. Obviously V. So by the various paths, by this we can calculate the critical path which is taking maximum duration. Okay. So the minimum duration. So the critical path is T, T, V, so 7, 9, 4. The total critical duration is here 20. Okay. Because here the time is 7 plus 9. Okay. Here the time is 4 plus 2 plus 9. Okay. Oh, sorry. Here the time is maximum. We have to find out the maximum for the critical path. Maximum power time. Okay. Next, a company is planning to procure a machine to produce a component. There are two alternatives available, machine A and machine B. The cost of producing X unit of component using machine A is given as CA is equal to 10,000 is plus 170x plus XA. The cost of producing X unit of the component in rupees using machine B given as CB 15,000 plus 400x. If the machine is to be preferred, then the minimum number of units to be produced should be So the two variations are given. Okay. Now, if the machine is to be produced, so for the machine to be preferred against A, okay, the cost of the machine should be less than B. Okay, for equal cost, we can equate these two equations. Okay, these and these. Okay. So by equating these, we find out x. These are the from this x is 250 and minus 50. 2 minus 20 cannot be the number of components, so B number of components is 250. So above 250, okay, uh, above 250, the machine A will be preferred, and below 250, changing in the answer is 250. Okay. Next, the availability of an old photocopier was 90%, and the mean time between failure MTBF was 200 days. It has been replaced by with a new photocopier having an availability of 95%. Now the mean time to repair, the time during which the photocopier is unavailable for service has increased by 5 days. The MTBF of new photocopier rounded off to nearest integer in days is, we know that availability is mean time between failure divided by mean time between failure plus mean time to repair. Okay. Now this mean time between failure is 200 and availability is 0.9. So mean time to repair is, we can calculate. Okay. Okay. When the availability is 95%, okay. So we can have this MTPR is equal to 27.22. Okay. So okay. So then again by putting in this equation we can find out mean time between failure. So answer is your 517.1. Okay. Next, a car company manufacture 200 units for a component per day. The component is installed in different car models at the rate of 15,000 units per year. The company operates its production facility 300 days per year to manufacture the component. The setup cost for each production run is rupees 200, and the inventory holding cost per year is 2 per unit. The economic order quantity is, we know that for economic production, when this R is given, R is your rate of then production rate is given and production rate is given. Okay. Uh, the formula for this economic order quantity is 2D0 0 1 minus R by T. So where D is under demand, okay, that is 15,000. D note is your setup cost and C1 is carrying cost. And R here consumption at 15,000 by 300, that is 50. And production that is given as 200. Okay. Putting this value, we can calculate value of the quantity, that is 2,000. Okay. Next, the company has to perform 5 tasks P, Q, R, S, and T to make an assembly. The task, time, and immediate processor of the tasks are listed below. If an assembly line is designed to obtain the maximum output rate, the efficiency of line in percent is, so or we have to calculate the efficiency of the line, we have to draw the uh, diagram, the project diagram. Okay, so this is the project diagram. So P is your 20. Okay, and after P there is Q, there is 25, and after Q there is R, that is 10, and after S there is sorry, after uh, Q there is S. Okay, there is 15. So after uh, R and S there is 25. Okay, so this is your project network. Okay, so the critical path to produce a simple component is easy. Maximum will be to 20 plus 25 plus 15 plus 25. Okay, that is the maximum path. Okay, or the critical time. Okay, as there are four activities, one, two, three, four. Okay, so we can divide it the four. Or we can give it as mean time for each process, that is 21.5. So the maximum time the activity is taking is 25. Okay, so the line efficiency is mean time divided by your maximum time. So answer is your 65%. Okay, the answer should be 65%. Next, in a work study experiment, it is observed that the worker completes the job in an average time of 15 minutes with a performance rating of 120%. The time required for another worker having the performance rating of 80% to complete the same job rounded up to one decimal place. So average time is 15 minutes. Okay, rating is 120%. Okay. Now the standard time is 15 into 120, 1.2. So that is standard time. Okay. Average time into rating is standard time. Okay. And for worker 2, the standard time is 15 into 1.2. Okay. As the and average time is your standard time is your 15 into 1.2. It should be rating is 120%. Okay. So it should be 15 by 1.2. Okay. And here the standard time. The time was created in the document. So this will be 15. Average time is 15, okay. And the standard time is 15 by 1.2, and it should be multiplied by 0.8. Okay. So answer is 22.5. The work completes the job 15 minutes with a performance rating of 120%. Time required for another worker is performance rating of 80%. Okay. So now the standard time is your 15 by 1.2. Okay. And so it should be 15 by 1.2 into 0.8. Okay. It should be 15 by 15 by 1.2 into 0.8. Okay, so the average time for the probability of 80% will be 22.5. So answer is here 22.5. Okay, standard time is. Thank you. This is last question. Okay. Thank you.